Hi and Assalamualaikum. Today we will be going to discuss a topic about an application of differentiation. First, let me introduce my amazing group members. We have Nurul Najma Atira binti Suhaimi, Nur Haziatul Salwa binti Cik Hassan, Kistina Adriana binti Muhammad, and me myself is Nurul Ayuni binti Raziat. We are from AS1202J and we will be presenting the solution we have got for the question that we chose.
So first thing first, what is differentiation? Differentiation can be defined as a function process to find its derivative. The derivative of a function gives the rate of change of the function. It is also functioned with respect to a variable determines how the variable affects the function. So next, when do we apply differentiation? Differentiation was applied when we want to determine the instantaneous rate of change of quantities. It is also used when determining the speed or distance of moving object. On the other hand, the derivative was used to find the maximum or minimum value of particular function. So, we can apply a differentiation in many solutions. Let's say we can use it in relate street, analysis of function 1, analysis of function 2, apply maximum and minimum problem, and the last we can use it in Ross theorem and mean value. What is maximum and minimum problem? First, that is the process of finding maximum or minimum value is called optimization. Many application problems in calculus involve function to find maximum or minimum value. So how do we apply maximum and minimum point? First, we need to identify all given quantities to be determined. We can define our variables. If it is possible, make a sketch. Second, we need to determine the restriction of the variable. Third, find a secondary equation that relates to the problem. Fourth, write primary function for the quantity that is to be maximized or minimized. Fifth, find a secondary equation that relates to the problem. 6. Use the primary and secondary equation to create a function where you plug the secondary function into the primary function. And the last thing, we need to take the derivative of the function, set it equal to find the critical points and determine where the relative maximum or minimum is.
For the problem statement, a closed cylindrical can of radius r and height is to have a volume of 120,000 cubic centimeter. As we can see, the volume given is 120,000 cubic centimeter. A. Show that the surface area is A equal to 2 pi r square plus 240,000 over r. And B. Find the radius that minimize the surface area.
So now, we move to solution. Okay, for this solution to question A, show that the surface area A equal to 2 pi r square plus 240,000 over r. For the first step, we need to know what formula we need to use for the question and write a formula first. For the question, we use the formula area of cylinder A equal to 2 pi r square plus 2 pi r h and the volume of the cylinder formula V equal to 2 pi r square h. Why we use this formula? It is because we need to show for this formula we can get the given surface area the same as the question. Next, step 2 is identifying. We need to read a question and get the given information. The given information that we got is the volume of a cylinder is 120,000 cm3 and to find H value. Move to step 3. We need to determine the value of H. For this solution, we can use a volume formula. Since we just know the value of volume, which is 130,000, and from that we can get H value. So, pi r square H is equal to 120,000, and we just move pi r square to the right, and we got only H at the left, and this is a H value, which is H equal to 120,000 over pi r square. Last step is to assign the value of H. For this step, we need to use the area formula to show that the surface area same like equation. So, we just put H value to the formula, and finally, we can see that from the question, which can show that the surface area is A equal to 2 pi r square plus 220,000 over r. Move to the B question. Find the radius that minimize the surface area. Step 1 is identifying. Same like question A. We need to read the question back and list what we got for the question. The information that we got is the area equal to 2 pi r square plus 240,000 over r. Then, we need to find r value and conclude whether this is the minimum or maximum. The second step is find the derivative. We just need to differentiate the value of A, and we got the A prime, which is 4 pi r minus 240,000 r square negative 2.
Step 3. Let the derivative equal to 0. We just need to put A prime equation and equal to 0 to find the value of r. So, the value of r is 26.73 cm. Let's move to the last step for this question. The last step for this question, we need to find second derivative. A2 prime equal to 4 pi plus 4,180,000 r negative cube when r equal to 26.73 cm. Basically, we just need to differentiate from A prime step 3 and just insert the value of r. So, 37.70 bigger than 0 and it is minimum.
In conclusion, after doing all of the calculation, we can see that differentiation plays a crucial role in optimizing dimensions, such as maximizing volume or minimizing surface area, and analyzing rates of change in problem involving cylindrical cans or similar shapes.
By the way, this is our reference for our video presentation.
That's all from us. Thank you for watching.
Bye!